Meet the next generation electrosurgical analyzer, the Fluke Biomedical QA-ES3. This all-in-one analyzer offers improved functionality, accuracy, and ease of use over its predecessor, the QA-ES2. The QA-ES3 collects all measurements including vessel sealing, high-frequency HF leakage, contact quality monitor, and output power distribution in single or continuous mode. It also measures cut and coag waveforms with either monopolar or bipolar outputs. The automatic power distribution feature allows automatic measurement of power, current, peak-to-peak voltage, closed load only, and crest factor. The addition of automation speeds up testing and helps reduce human error. At first glance, you'll notice the QA-ES3 has been redesigned to reduce the number of connections. All of the multi-purpose ports are accessible from the front, along with function keys and a selection knob. The large LCD screen is easy to read, and on-screen guides are designed to guide you through testing. When you pick up the QA-ES3, you'll quickly discover it's lighter than the previous version, 5.5 pounds lighter. Everything you need to test all critical functions of today's high-power electrosurgical units is either integrated into the design or included with the unit. There's no need for extra cables, leads, or switch boxes to test precision power, current, frequency, crest factor, and load resistance ranges. The state-of-the-art technology, the QA-ES3, provides exceptional accuracy and range of measurement. Its wide range of loads allows users to test the breadth of electrosurgical generators. Notably, the QA-ES3 has a 20-ohm load to support Valley Lab electrosurgical units, including the Force Triad. The QA-ES3 also has double the RMS current range of its predecessor. It can measure current from 0 to 5500 milliamps. Plus, it's twice as accurate with current accuracy, 2.5% of reading, plus 1 milliamp for all loads. It's exceptionally accurate with generator output power accuracy of 5% greater than 10 watts and 5% plus 1 watt otherwise. In addition, it provides a load resistance accuracy of 2.5%. The QA-ES3 is also highly precise with a tenth of a watt resolution up to 99.9 watts and 1 watt above 100 watts for power measurement. Featuring a universal power supply and in compliance with global standards for testing electrosurgical devices, including IEC and ANSI/AAMI, the QA-ES3 can be used worldwide. It can store up to 5,000 records, making it convenient to store results and retrieve later. Also contributing to the QA-ES3's reduced test times is its Bluetooth wireless capabilities, which makes it possible to quickly and conveniently transfer results to a PC. The addition of Answer software further automates and standardizes testing, speeding up overall test times and minimizing human error. Answer software can produce a single electronic test report, which displays all preventative maintenance tasks, including visual inspection, electrical safety, and performance characteristics. The QA-ES3 is an all-in-one analyzer to get the job done accurately and quickly. With industry-leading specs, the QA-ES3 can test all modern high-power electrosurgical units. To learn more about the QA,
we have a real simple setup. All we need to do is hit flow on the test. We would put in any patient name if we had any. We're just going to skip through. We're going to connect the pump as it requests. We already have. I just showed you that. And the most important thing here is notice the red bar. That tells you the device is not primed. This is where the syringe comes in. So as I press on the syringe, you'll notice that the blue bar, or the red bar, shows up as a blue bar. There it goes. And once it is completely blue, you're actually ready to go. Don't forget to change your switch to close the syringe and open your infusion device. So at this point, all we need to do now I'm going to start my infusion device and I'm going to start the test at the same time. Start and start. We should see some numbers coming up shortly. There they are.
Introducing the ProSim 3 Vital Signs Simulator by Fluke Biomedical. It's portable, user-friendly, and full-featured. The ProSim 3 was engineered for field testing. If you need a portable simulator, the ProSim 3 is for you. You'll quickly notice the size and weight of the simulator. In fact, it's 20% lighter and 25% smaller than its predecessors. Lightweight and battery-operated, the ProSim 3 is equipped to go all day. Notice how the ProSim 3 only has a few buttons. This simple interface allows for rapid testing and ease of use. The ProSim 3 also has a large screen, making it easy to navigate and manage parameters. It's full-featured, making it ideal for use on the floor or in the lab. The ProSim 3 simulates ECG, invasive blood pressure, temperature, cardiac output, respiration, and some fetal simulations. With 4 IBP channels, the ProSim 3 can test even the highest acuity scenarios. It can also be paired with other devices for comprehensive testing. Let's take a closer look at its basic testing capabilities. The ProSim 3 tests many functions needed to troubleshoot and verify the accuracy of a patient monitor. Its ECG testing capabilities include normal sinus rhythm, various arrhythmias, performance testing, pacing, and fetal heart rates. Today we'll demonstrate how to simulate changes in ECG. We'll manipulate beats per minute and then introduce an arrhythmia. For the purpose of this demonstration, we'll test using battery power. The ProSim 3 will bring up the parameter selection menu. From the home menu, select ECG. Press Enter. Press the right navigation button and select the desired beats per minute. Press Enter. We've now changed the beats per minute. To go back to the home menu, highlight Home and press Enter. Select Arrhythmia. Press Enter. Select an arrhythmia and press Enter. We have just introduced an arrhythmia. The Fluke Biomedical ProSim 3 Patient Simulator is portable, easy to use, and full-featured. It's a clear choice for biomedical engineers and field service techs that need a quality, feature-rich device. The ProSim 3 Vital Signs Simulator by Fluke Biomedical. Fluke Biomedical.
2 functional tester, the newest member of the ProSim family. The scenario that we're going to talk about today is one that happens every day in the medical facility or hospital, where you get a call from the clinical unit. The oximeter is not working on some medical device. So you grab your spotlight and you go up to the clinical unit. In this case, we find the device turned on. It's a defibrillator, and we will turn on our spotlight SpO2 functional tester. Wait for it to go through its self-check. And we will then connect the oximeter sensor from the medical device, and we'll watch this bar down at the bottom. It's called the signal strength bar, and you can see that it has a good signal, and you will begin to see the display on the screen of the defibrillator. Now, testing this functionally really quickly is just a 4-button push. We're going to go to our custom setup and go to Custom 3, which is programmed for a patient with a high heart rate and a high O2 sat. You can see it sets off the high limit alarms, which is exactly what we want it to do. We'll watch till the oximeter reading and the heart rate settle. And then we'll move to Custom 2, which is a normal patient. We want to let the alarms continue to sound because the normal conditions will let them silence on their own, an important part of the functional test. Again, waiting for those to settle, and then we'll simply push one more time for our hypotensive patient with a low O2 saturation, low perfusion. And you'll see the alarms will sound again, this time on the low end. And again, we'll wait for the readings to settle. And we'll push one more time to get back to a more normal reading so the alarms will quiet once more. And there we are. You've tested 90% of it in right around 30 seconds. The SpO2 functional tester, Spotlight, the newest member of the ProSim family.
Something was definitely this machine, some bad readings. Yeah, one we're way over. And typically there's a couple of things you can try, but what it usually is, yeah,
there's something definitely wrong.
Yeah, if it's not the cord giving you an issue, which sometimes it is,
Okay.
just by wiggling the cord, you'll see a dead
Different
change. You know, but that's not what's going on. The other thing is that a lot of times the sound head or the holder is pressing down on this.
Mm-hmm.
And you'll see if you press down on it, it's
Changes.
going to change.
Mhm.
You know, sometimes that happens. Something happened. Cone's
So
not
there's
in.
stuff to do
Exactly.
before you freak out and say it doesn't
Exactly. You know, and if
work. Troubleshoot, basically.
yeah, you know, if that all seems to be in place, none of those, you know, things are, you know, interfering with that, you got a calibration issue,
Okay.
you know. And I will show you how to calibrate this machine. Okay. Ultrasound. Okay. These,
All three of them at the same
yeah.
time?
And then stop. A butthole. Go over to the calibration mode. There we go. Now you'll see calibration.
Ultrasound calibration. You just press on that?
Yeah. So it's these three buttons
Start.
and then these two buttons here.
Okay.
Make sure your meter's on zero.
Bring it
Zeroed
back to
out.
0. Okay.
Get an accurate reading.
And start calibrating.
That's the calibration. You'll start seeing these numbers start to fluctuate down here as it's searching.
So this is basically searching for a problem.
It's
Kind of troubleshooting itself.
It's troubleshooting itself, yeah, and it's looking for calibration information.
Okay.
You
And
know,
then it gives you a reading. Just tells you what's wrong.
And it starts you off. You'll see, because there's boards in here. There's also a board in the sound head itself, so it's communicating back and forth with the sound head, trying to find the right frequencies.
Well, that's good.
Okay. So now it's telling you to set your meter to 4 watts. Okay.
Change it back to.
What most people do is they'll start spinning the dial or looking at the machine, expecting it to start showing
Okay.
wattage.
Okay.
No, pay attention to your meter. As you're ramping it up, you'll notice this starts going up. As soon as this
4
meter
watts, you said?
reaches 4 watts, and it comes up quickly too.
Okay.
Usually right up around 300 to something 300. That's where you'll start seeing it start getting up close. And if you spin it too quick,
You might miss it.
you'll miss it. And it's kind of a pain to have to go back.
Mm-hmm. It's almost there.
Oh.
There. Okay.
It's very easy to go past it. You want it right on 4.
Okay.
Just kind of wait, make sure it's stable.
Mm-hmm.
And next. And I'll have you do it on 3.3 megahertz as well. And again, you're looking for 4 watts on 3.3 megahertz. There's been times where I'm not paying attention. I've ramped it up and my meter's showing 10 watts. I'm going, oh crap. Go all the way back
all the way
down.
back, start all over again.
Yeah.
Next.
Good. And it kind of walks you through it.
Remove applicator from water. Okay. Next.
Let's save the calibration data.
Data.
Once it's clear.
Okay.
You should be good to go. If it doesn't
So
calibrate it again and you're still off,
Then you gotta replace something in this thing, right?
no.
No.
It's the board in this.
Okay.
And I'll show you what you need to do.
Okay. You guys replace the boards too, right?
Oh yeah, they're real simple. Right at 1. Right at 2. Right at 4. Just about right at 5.
Last one's 10.
Point 2. up to 9.4, but we're
Which should be-
within-
that's
yeah,
good.
we're still within the 10%. You know. Make a liar out of me, machine.
So freaking sensitive.
Yeah, they are. Here, go back up a little bit.
Oh, it's going wild.
Yeah, you'll get some wild numbers. It will settle down once the water stops moving.
Moving.
Yeah. Okay.
That's good, right?
Yeah,
9.4.
we're right good. Okay. So it did calibrate. It's usable.
Everything's okay.
Yeah. I've got a sound head